So if we're going to look at groundwater pollution, it's obviously going to be a little bit different from surface water. How's the flow in groundwater? Slow. It's slower. So contaminants are not going to be diluted as fast or at all compared to like a river or stream. How about dissolved oxygen levels? Less, okay? And fewer decomposing bacteria. So if you want to compare that to surface water, there's your comparison. You didn't find it? Yeah. If you go, anybody know what wastewater is? No. Think about the way the word says it. Wastewater.
Water that's waste, that has waste in it. Or is wasted.
That actually both are good. So water that's wasted and water that has waste in it. So it's basically water that leaves your like home, whoops, or industry or whatever. It's water that goes down your faucet in a sense, and it produces what we call sewage sludge, which is full of toxic chemicals, because you know in that water you've got all sorts of things, because water is a universal solvent. What's interesting is what it can form, and that's going to be one of the solutions coming up in a minute. These are the terms that are associated to cultural eutrophication, or what they call artificial eutrophication, or hyper-eutrophic lake. You're going to have runoff of phosphate and nitrogen that's found in fertilizers or cleaning products, but mainly this is caused due to agricultural industrialized farming, I would say. So that leads to a bloom of algae or excessive growth of algae, and you see that here, right here, a eutrophic lake. And then the algae will die because it's overpopulated, so it's limited resources. And then in order for the algae to decompose, you have oxygen demanding bacteria. And I didn't put that there, so please add it. Oxygen demanding bacteria break down the algae. And obviously, if they're oxygen demanding organisms, they're going to reduce the levels of oxygen in the body of water. And then fish will suffocate and die. The other version is if you have this algae growth on the top of the water, light is going to be reduced throughout the body of water, which also leads to less oxygen because less photosynthesis, etc. Thermal pollution increases temperature, and what happens because the temperatures of the body of water increase? Good. Dissolved oxygen decreases. What causes thermal pollution? Good. Power plants discharging their water, which is used for their cooling system, which we'll learn about eventually. And industry, of course. What type of water or body of water accumulates the most pollution, lakes or rivers? Why river?
Because more people like travel on rivers.
That's actually a really good point. Transportation. But it's wrong. Why? Because they don't move, okay? So it's always going to be lakes because rivers have a flow, and when there's a flow, there's a better chance of diluting of pollutants. So in a sense, and think about it, the same way people travel through rivers, they actually travel through lakes, but that's going to be stagnant. Nothing will stir up the molecules, let's say, and break them apart. So they're kind of more concentrated in a specific area. Does that make sense? Kind of hurts the lesson, I would say. Let me just do the revealer so we could go in order. All right, so water has to be processed. The water that gets to your home comes from where? A lake, okay? And in a lake is what? Bacteria, life, nutrients. Everything runs off into a large body of water. So, you know, it's funny because when you think about drinking sewer water, everybody's first initial reaction is what? But a lake is kind of the same thing, right? It's non-flowing water and we drink from it. So it has to be processed, right? So, and I've been to our water plant and they do a great job. Problem is that after they do the great job, it has to go through pipes to your home. That's where I have a problem. But this is what they do. And if you ever visit a water plant, you'll see all these pools of stations, I would say. The first one is a filtration station. Makes sense, right? You want to remove any large, that LG means large particles. So they kind of use like these big filters and the water travels through the filters and you'll see the sediment buildup on the top of of the first filtration system. And then it goes through what they call coagulation. They add aluminum to the water. So this is not written there, so you want to make sure you put add aluminum, and this is added to remove bacteria from the body of water. So we mentioned a lake will have bacteria and a lot of different pathogens, so we want to remove those. Then we go through an additional filtration system, so anything that might have gotten through the first time or even accumulated, because particles reaccumulate, will go through a second filtration system and they'll remove those particles. And then this is what most of you or some of you taste in your water or smell in your water at times. After the water has been processed somewhat, they add chlorine to make sure that bacteria does not regrow. And I could tell you, if anybody have a fish tank? So if it's fresh water or salt water? Fresh. So when it's fresh water, what do you have to do before adding water to your tank? You have to put a gallon of water and let it sit for at least 24 to 48 hours. And the reason is you're airing out the chlorine that's in the water, okay? Just like with our lab, the first thing I have to do is put a bucket of water and let it sit. So I could take the chlorine out, because if not, you'll kill the fish, okay? Aeration, this is pretty cool. Not all water plants have this, but not the one that we have. They have these towers where they actually break apart molecules to remove any unwanted odor or gases. And then, this is the last thing, they add treatment, like add fluorine, fluoride, lime for taste, okay? And for improving your teeth, really. What are some problems with groundwater? And anything that happens in the ground can lead where? Where does groundwater flow to? Ocean or a lake. So it's gonna end up on surface water, because groundwater is the last stage of runoff. If water goes through the full cycle, groundwater, which is an aquifer, will flow into a large body of water. And I don't know what it says here. Oh, so all these things are falling on land and will be part of the water cycle, because they go and get dissolved in water somewhat. So they percolate, infiltrate, and end up in this body of water. And from agriculture, you have excess phosphorus, nitrogen, and pesticides. On land, you can have leaking gas tanks and industrial waste ponds with no liners. And we're going to talk about this when we do the land chapter. Most landfills are sanitary, so liners is a part of it, but back in the day they weren't, so this is still a topic. All right, other problems with groundwater. The withdrawal rate. What do you think the problem is? Yeah, so it's faster than the replenishment. So pumping exceeds replenish, and we know that that's overconsumption, or the United States in general, yeah? What does it lead to? Oh yeah, you wouldn't know this. Salt intrusion and sinkholes, or subsidence, which is basically a drop in the land. And I'll show you a picture of it. I'll move on to the next page. I thought I had a picture of salt intrusion. I don't, but I will in the next chapter. But this is what a sinkhole looks like, okay? So you have a drop in, let's say, the levels of water underground. That makes sense, right? That above ground can have this situation. I'll go back for you to finish writing. Does freshwater have salt? Yes, that's why I needed to say it in the video. So it's not salt-free. It just doesn't have enough parts per million to be considered salt water. It still has salt. So any kind of exceeding withdrawal can leave that residue left over. And you'll see, even in agricultural farms, when I get to that chapter, when the water evaporates fast, salt is left on the fields, which obviously affects future food production. That's why it's saying that. But we're going to talk more about that in the upcoming chapters. I think I have to